Hi, welcome back to the YouTube channel. In today's video, we're going to look at how to find the directional derivative of a function at a particular point, where the vector will be given to you. Now, let's quickly get started on this particular problem. So the function we are given here is a function of x, y, z. I think everyone can see basically it's a function of x, y, z, right? And we are to find the directional derivative of this particular function in the at the point 1, 2, minus 2 in the direction of this unit vector v. Now let's quickly pull up the formula for calculating this directional derivative. So here it is. So for any function f of x, y, z at a particular point x, y, z, directional derivative is just the inner product. Now you'll be asking inner product of what? It's just the inner product of the gradient vector. And mind you, this gradient vector will be evaluated at this particular point x, y, z, and the unit vector v. So in this case, so let's quickly write this, right? So is the inner product of these two vectors, the gradient vector, which is gotten from this, and then the unit vector. The unit vector u in the direction of v, right? Unit vector u of v. Okay, so let's say in this problem we have a vector v, which is not a unit vector. The first thing that we have to do is to convert it into a unit vector first before we use it in this calculation. So let's just get started. So first thing that we have to calculate the gradient vector. So how do we calculate this? Like I said in this formula, it's just basically we need to calculate fx, fy, and fz. So which means so let me use this notation for the vectors. Now what happens is, in order to find fx, we need to find the partial derivative of this function of f of this x, y, z with respect to x. So let's do that. Now, everyone knows that when you have square root of x squared plus y squared plus z squared, in order to find the partial derivative with respect to x, it has to be through chain rule, right? So which means that we have to find the derivative of the square root first, multiplied by the square root of the function inside. So when we do this, derivative of the square root would give us 1/2 of the square root. Now we now multiply this with the derivative of the inside with respect to x, which will just give us 2x. Now, for anyone who wants elaboration on this, just think of this as your f is square root of u, where u is x squared plus y squared plus z squared. Now you can use chain rule now to find partial derivative with respect to x to be partial derivative with respect to u multiplied by what du dx. Now when you do this, you get exactly what I have here, 1/2 square root of x squared plus y squared plus z squared. Okay, good. And then of course multiply by 2x. Okay, now when we simplify this, we basically see that this is x over square root of x squared plus y squared plus z squared. Quite easy, right? Then we do the same thing for y. We have the same thing, just that this time around we have y over square root of x squared plus y squared plus z squared. And finally, for fz, similarly, we'll have z over square root of x squared plus y squared plus z squared. Now, so the next thing is we need to evaluate this gradient at the point that is given. Remember, we are looking for this at a particular point, 1, 2, minus 2. So we need to evaluate this at 1, 2, minus 2, right? So in order to do this, so this is fx evaluated at what? 1, 2, minus 2, fy at what? 1, 2, minus 2, and fz at 1, 2, minus 2. Okay, so let's see what does that amount to. Okay, so the first one would be, remember, is x, which is 1. We have x over square root of 1 square plus 2 square plus minus 2 square. Okay, and we have the same thing for y. It's going to be y. Remember, y is 2 here, so it's going to be 2 over the same thing, 1 square plus 2 square plus minus 2 square. And finally, we have z, which is minus 2 over square root of 1 square plus 2 square plus minus 2 square. So I'm kind of using a different notation for vector in this particular context. So let me not mix things up. So let's use this as our notation for vector. So let's quickly calculate this. So this gives us 1 over, so this is 1 plus 4, that's square root of 9. So that's going to be 3, 1 over 3. Here's 2 over 3. Here's minus 2 over 3. Now let's finish this problem. So the directional derivative of this function in the direction of u would be the inner product of the gradient vector at that point and the unit vector that we have minus 2 over 3. So we have minus 2 over 3, 2 over 3, minus 1 over 3. And we all know how to find the dot product, just the dot product of these two vectors, so which is 1 over 3. So it's the first component multiplied by the first component plus the second component multiplied by the second component plus the third component multiplied by the third component. So we have this times minus 2 over 3 plus 2 over 3 times 2 over 3. And finally, minus 2 over 3 times minus 1 over 3. So this gives us minus 2 over 9 plus 4 over 9 plus 2 over 9. And that gives us, I think when we add this together, that will give us 4 over 9. So, and that will give us the directional derivative of this function at that point in the direction of v. Now, there's a caveat in this problem. So, what if the case was v was given? So let's say v was given in this problem as minus 2, 2, and minus 1. So the first thing that you have to do before you proceed with this formula is, remember here we need the unit vector, right? So we know that our directional derivative, the overall formula is the inner product of the gradient vector and what? The unit vector in the direction of v. So the first thing is that we need to convert this v to a unit vector. So in order to convert v to a unit vector, all you need to do is to divide v with the length of what? V. Okay, this is what you need to do. Now, what is the length of v? Length of v is basically the square root of, so in this case, you would have had u and v divided by square root of what? The first time square. This is how to find the length of any vector. It's just the square of each of the components in the square root. And that would have given us minus 2, 2 minus 1 over 3, right? You would have square root of this over 3, which is actually what the question has done for you. The question has actually found the unit vector for you to solve this problem. In case you don't have the unit vector in the direction of v, you have to find that first. So this is how the problem became this. And that was used in solving this problem. So just in case you're not given a unit vector, you have to convert that first. And then find the dot product of that with the gradient vector at that point. All right, so that solves the problem. The problem is, the answer to this is 4 over 9. And that will be the end of this video. If you have not subscribed, make sure you subscribe to this channel to help the growth of the channel. And then like and comment below any video you'd like to see in the channel. I'll be more than happy to make the video for you. And then I will see you guys in the next video.